In this video, we're going to look at some exam questions on alcohols. Now, here is our first question. This question is saying, what is the product of the reaction when the given molecule is introduced to an acidic solution? This question is very simple, and we know that this question is being derived from the chemical reactions of alcohols. But which type of reaction? Which type of reaction is this question being derived from? Well, it has been derived from the dehydration of alcohols. This is the chemical reaction that we need to understand for us to answer the first question. So, this particular reaction is called dehydration of alcohols. So, when you perform this reaction, what you're basically doing is that you're just converting an alcohol into an alkene. Now, you need to understand how this process happens. So, what happens here is that you have to remove the hydroxy group. So, you can see this is the hydroxy group right here. So, this is removed, and you also have to remove the hydrogen atom from the alpha carbon. So, we know that the alpha carbon is this carbon here, this carbon, which is right next to the carbon that is connected to the functional group. So you remove the hydroxy group, and also you also remove the hydrogen atom from the alpha carbon. So when you do that, you're going to have an alkene being formed. It is very important to note that our products are two here. We have an alkene and also a water molecule. So this water molecule is coming from this hydroxy group that is removed, and also the hydrogen. So when you combine these two things here, they'll give you a water molecule. So that is where that water molecule is coming from. Having understood the dehydration of alcohols, we're ready now to tackle our question. So, from the knowledge that we got from the reaction of dehydration of alcohols, we know that what we're supposed to remove from this particular molecule are two things. We're supposed to remove the hydroxy group, the functional group of the alcohols. That is number one. We're also supposed to remove the hydrogen from the alpha carbon atoms. So, removing the hydroxy group is very simple because we know that we have this thing is the hydroxy group. Then when it comes to the alpha carbon atoms, we have two alpha carbon atoms. We have carbon number one. Carbon number one is the alpha carbon. Carbon number three is also the alpha carbon atom. So in this case, we have a dilemma. We need to decide which alpha carbon should we go for. Is it carbon number one or is it carbon number three? So to decide whether we should go for carbon number one or carbon number three, we have to look at how these two carbon atoms are substituted. So when you look at carbon number one is only connected to carbon number two. So in other words, carbon number one, which is this carbon right here, is only connected to carbon two. So it is connected to one carbon atom. Wow, if you consider carbon number three, which is this carbon here, this particular carbon is connected to two carbon atoms. It is connected to carbon number 4 and carbon number 2. Therefore, we are going to go for carbon number 3 as the alpha carbon, where we're going to remove the hydrogen atom. This means that what we're basically going to remove are two things. We're going to remove the hydroxy group, and we're going to remove this particular hydrogen from this alpha carbon atom, and we're going to put a double bond right here. So when we remove those two groups, the hydroxy group and the hydrogen, then we put the double bond there. That is going to be the product of this particular reaction. So this is our product after removing the two groups from the alcohol. So our answer is 4-bromo-2-hexene. Let's look at our second question. So this is our second question, and this question is saying which reagents would achieve the given synthetic transformation. So in this question, we have been given this equation. This is the equation right here, and this equation does not have the reagents that are needed to get the product that we have. So notice what we're starting with. We have this alcohol right here. This is an alcohol, and this alcohol is being converted into a carboxylic acid. This is a carboxylic acid right there. So now we need to find out the reagents that can transform an alcohol into a carboxylic acid. So basically, this question is being derived from the reactions of alcohols. And to be specific, it is coming from the oxidation of alcohols because you can oxidize alcohols to get carboxylic acids. So let's look at what we need to know first of all before we answer this particular question. This is the information that we're required to know for us to answer question number two. And this information is nothing but the oxidation of alcohols. So if you have a primary alcohol like this one, you can oxidize it to produce an aldehyde, which you can also further oxidize to give you a carboxylic acid. So if you have a very weak oxidizing reagent, you are going to produce an aldehyde. If you have a very strong oxidizing agent, you are going to produce a carboxylic acid. So you need to know which type of reagents to use if you want to get an aldehyde or a carboxylic acid. So this is how oxidation happens for primary alcohols. If you have a secondary alcohol, you can oxidize it to ketones. So you can only produce ketones if you have a secondary alcohol. You can only oxidize a secondary alcohol to produce ketones. If you have a tertiary alcohol like this tertiary alcohol cannot be oxidized. So tertiary alcohols do not undergo oxidation reactions. Now let's talk about the reagents that we need to have for us to produce aldehydes or carboxylic acids. For you to oxidize a primary alcohol into a carboxylic acid, these are the reagents that you need to have. You can use potassium permanganate to oxidize a primary alcohol into a carboxylic acid. You can also use chromic acid. Chromic acid is also a very powerful oxidizing reagent. Now, chromic acid is not available, it's not readily available. So, if you want to form chromic acid, you have to combine sodium dichromate and sulfuric acid. So, in other words, instead of writing chromic acid as a reagent, you can write sodium dichromate and sulfuric acid because those two will react and chromic acid is going to form in the process and it's going to oxidize your primary alcohol. You can also use potassium dichromate and sulfuric acid. Those two will also react to give you chromic acid, which is going to oxidize the primary alcohol. You can also use Jones reagent to oxidize any primary alcohol into a carboxylic acid. So if you use any of these reagents that are listed here, you'll be able to oxidize your primary alcohol into a carboxylic acid. This means that to answer question number two, you can actually pick any of these oxidizing reagents that I have underlined. If you want to oxidize a primary alcohol into an aldehyde, you can use a reagent called PCC. So PCC stands for pyridinium chlorochromate. So in short, you can just call it just PCC. That'll be fine. So if you use PCC, you're going to oxidize a primary alcohol into an aldehyde. PCC is a weak oxidizing agent. And so by using this reagent, you won't end up producing a carboxylic acid. Instead, you just produce an aldehyde, and that will be the end. So PCC can be used to oxidize both primary alcohols and also secondary alcohols. Now, you must note that if you use PCC to oxidize a secondary alcohol, you're going to produce a ketone only. So you must know that if you use PCC to oxidize a secondary alcohol, you're going to produce a ketone. While if you use PCC to oxidize a primary alcohol, you're going to get an aldehyde. So let's look at our third question. So our third question is saying which of the following molecules are capable of being converted into an aldehyde in one step? So that is the question right there, and we have possible answers. So you can see this first molecule is our possible answer. Then we also have another possible answer right there. Okay, you can see that particular alcohol. Then the third choice is that particular alcohol right there. So which one is the answer here? Well, if you look at these alcohols, this particular alcohol, the first one, is a tertiary alcohol. So for you to be able to convert an alcohol into an aldehyde, you need to have a primary alcohol. So you can convert a primary alcohol into an aldehyde using PCC. So this is a tertiary alcohol and it doesn't qualify to be the correct answer. When you consider the second choice here, this is the correct answer because this is a primary alcohol and we can turn this primary alcohol into an aldehyde using PCC. The last choice doesn't qualify to be a primary alcohol, that is a secondary alcohol, and we cannot convert a secondary alcohol into an aldehyde. We need to have a primary alcohol that we can convert to an aldehyde using PCC. So the correct answer is our second choice. This is our fourth question, and it's saying, what is the product of the following reaction? So this particular reaction involves an alcohol. This molecule here is an alcohol because of this functional group, the OH group. So we are able to tell that this particular molecule is an alcohol. And this particular alcohol is reacting with this reagent. This is potassium permanganate. Potassium permanganate is a very strong oxidizing agent. Now let's look at this alcohol that we have here. This particular alcohol is a primary alcohol. So we know that if you react a primary alcohol with a strong oxidizing agent, you're going to form a carboxylic acid. So basically this reaction is just converting this particular primary alcohol into a carboxylic acid. So to write the answer, we need to remove these two hydrogen atoms right here and replace them with an oxygen atom. So meaning our product for this particular answer is going to be CH3, then CH2. Okay, then we have 2, meaning we have two CH2 groups. Then we can write this carbon, then two oxygen atoms. So this is the answer for this particular reaction.